Hello there, this is a geometry video. It is chapter 8, section 6, and today we'll be talking about two different laws, the law of sines and the law of cosines. So first up we have the law of sines, and I want to show you the law of sines and the law of cosines basically apply to triangles that are not right triangles. We've already discussed in the previous sections how to solve a triangle that's a right triangle, but what about when it's not a right triangle? And that's what we use law of sines and law of cosines for. And you might recall that you did the congruent triangle theorems, you know, where you had angle, side, 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 and that kind of thing. You're going to see that here again as well. And so first up, law of sines is going to deal with angle, angle, side, and angle, side, angle. And before we get to that, I want to just tell you what the law of sines is. It's basically when you can set up a proportion. Now you don't have to have three different parts, but all of these proportions or ratios are equal to each other. So depending on the information given, you might want to use angle A or angle C, and then you don't need angle B. Or you might have A and B, and then you don't need angle C. You only need to have two ratios at a time. So basically you have your triangle. All of the capital letters represent the angles of the triangle, and the sides are the opposite of the capital letter in a lowercase letter. So here's angle A, and so the opposite of that is side A. And to distinguish between the angles and the sides, we have basically lowercase and uppercase letters, with the exception of C. Not that it's an exception, but it kind of looks weird. It's kind of hard to distinguish between a capital C and a lowercase c, unless they're actually next to each other. So just do your best. But anywho, we're going to get started to show you how this applies. Oh, I'm sorry, I didn't even tell you what the theorem was. So once we know what all the different parts are, we know that the sine of angle A divided by the side A is equivalent to the sine of angle B divided by the side B, and also equivalent to the sine of angle C divided by side C. So that's basically your theorem or your ratio, or your proportion that you're going to want to use. So we're going to go here, and this is an angle, side example. And it says find x round to the nearest tenth. And we know that it's angle, side because that's the information that is given. Okay, so we don't know what x is here. So if we're not including x, you can see that you are given angle A, 97 degrees, angle C at 21 degrees, and side BC. But the side that we're given is not in between the two angles. That's why it's angle, side. And so to find x, we're going to go ahead and say that since we know that angle C is 21, we're going to use the sine of C, which is 21 degrees, and then you divide it by the opposite length. Did I say side? I meant angle, sorry. Angle C, and so you divide it by the opposite side, which is x. The other part that I'm given is angle A. So then we're going to do sine of A, which is going to be sine of 97 degrees over the side length A, which is 16. Notice how we don't know the measure for angle B, nor do we have the opposite side of B. So in that case, this is what we would use. We're going to use angle C and angle A. And so in this case, angle B is not part of our proportion, and we don't put the third part. We just need two at a time. And at this point, we just solve it. So we're going to get x times the sine of 97 is equivalent to 16 times the sine of 21. And then to solve for x, we're going to divide by sine of 97 on both sides. And again, it's important that your calculator be in degree mode. And so I'm going to go 16 sine 21, close my parenthesis, divided by sine of 97, close parenthesis, and I get that my answer is approximately 5.777, or basically 5.78. But it also said in the instructions that they wanted us to round to the nearest tenth. So since it's 5.77, we're going to go with 5.8. That is our approximate value for x. And that's how you do it. It's not very complicated. Everyone loves the law of sines. So we want you to try these. So again, you can see that we have angle, and the side given is not in between the two angles. Same over here, you have angle, and the side given is not in between the two angles. But in our next example, we're going to have angle side angle where the side that's given is in between the two angles. So here we have angle 45, angle 73, and the side that is given is 10. So that's an angle side angle situation, and the side that we're trying to find is x over here. So again, it's not about the where the placement of the variable you're trying to find is at, it's about what is given. The information given is angle side angle. Okay, so when that happens, for any time you have angle side angle or angle side, you want to use the law of sines. And so it doesn't really matter that they've changed the letters on us. All that matters is that we have our angle, h in this case, so we're going to go sine 45, and then you divide it by the opposite side, so that's going to be x. And then we equate it to the other angle that was given, which is 73, but we don't know what the opposite side here is. But lucky for us, we know that the angles in a triangle should add up to 180. So we're going to take 180 and subtract 45 and subtract 73, and that's going to give us a 62-degree angle. And we need that angle because now we're going to be able to use sine of 62 divided by the opposite side, which is 10. So it's always the sine of the angle divided by the opposite side length. All right, so in this case, we're just going to do our cross multiplication. We're going to get x times sine 62 is equal to 10 sine 45. And then we're going to divide by sine 62 on both sides. I hope none of you are calling these sin, because that's one of my pet peeves. It's not sin, it's not cos, it's not tan. It's sine, cosine, tangent. Just because you abbreviate the word doesn't mean that you abbreviate when you're saying it. So here we're going to go 10 sine of 45 and divide that by sine of 62. And we get approximately 8.008. But again, we're rounding to the nearest tenth. And to this 8.00, we're just going to approximate it at 8. So x is approximately 8 in that case, 8.0. Awesome. So now we're going to have you try these two, and then we're going to move on to our next theorem or formula. It's more like a law, and that's the law of cosines. So in the law of cosines, you actually have 3 different scenarios as well. Just like before the law of sines, you have 3 different ratios. With the law of cosines, you have 3 different formulas going on here, but they're actually not as complicated as they might look. Again, we have our triangle. This time we went A, B, C. It doesn't really matter how you draw the triangle. As long as the opposite side is A and the opposite side is C, the opposite side is little b, you're fine. So here is your basic law of cosines. You take the side lengths, okay? These are the little letters are the side lengths. So you have a squared equals b squared plus c squared. But once you've taken a squared out, then the b and c that you see here are the same b and c that go here. And then because this is cosine a, that's little a there. So you'll notice a pattern here. For example, in the second scenario, it's just the same exact thing as the first one, but now you're solving for little b. So if b squared comes out, then the 2 missing sides that are left are a and c. So a and c go there, squared. And because a and c are here, a and c will also be minus 2ac here. There's the same ac, ac, bc, bc. And because this is little b, it's going to be cosine of big B. Because this is little c, it's going to be cosine of big C. So there's a pattern there. And once you pull out c squared, the only 2 side lengths left are a and b. So you have a squared b squared. And because you have a squared b squared, this is going to be ab. So there is a pattern there. Just wanted you to know that it does look kind of scary, but there is a pattern. So make sure that you follow that pattern. And so now we have example 3. It says find x round to the nearest tenth. And you can see here how we have side angle side. This time, the side lengths are given. BC is 9, AC is 11, and the angle between them, 28 degrees, is given. So when that scenario happens, you want to use law of cosines. And we don't know what x is, that's what we're trying to find. So we're going to say x squared Now remember what I said before, because like if you're trying to keep a hold of all the letters, it's going to just confuse you. So once I have the x squared out, I'm only going to use the other two sides, which are 11 and 9. So I'm going to get 11 squared plus 9 squared minus 2. There's always a minus 2. And then you use the same numbers that you used here. So times 11 times 9. And then it's going to be cosine of the angle that was opposite x. And the angle opposite x is 28. And if my pen will come back, we will finish this little guy up. There it goes. And now it's just a matter of doing the math. So 11 squared is 121. 9 squared is 81. 2 times 11 times 9 happens to be 198 cosine of 28. And then you want to take 121 plus 81 is going to give you 202 minus 198 cosine 28. And that's x squared equals. If you want to get x by itself, you're going to have to square root that. So that's what we're going to do now. We're going to take 202 minus 198 cosine of 28. Close that parenthesis. So the 202 minus 198 cosine 28 is going to give me approximately 27.2. And I'm going to take the square root of that. And we're going to get 5.21. And it wants us to round to the nearest tenth, so we're going to go 5.2. Alrighty. There we go. Okay, I'm not sure why my pen is delaying, but there you go. Alright, so now we're going to ask you to try this guy. Remember that once you've pulled out the variable that you're looking for, the x squared, it doesn't have to, you don't have to keep track of the ABC, because now you can see that we're using D, G, and F. But remember that you just need to take out the variable, then the next two sides that are left are going to be the ones that you want to use, and obviously we're going to use the cosine of 125 in this case. Alrighty, and the cosine is 62 over there. So we'll let you guys do that. And then we'll do another one for law of cosines. Not only do we have side angle sides for law of cosines, but we have side, side, side. So what if they give us 3 side lengths and they want us to find this angle there? So that's another time when we can actually use law of cosines. And again, same thing is going to happen. You want to take the angle in question is angle M, so we want the cosine of that angle at the very end. So we want to start with the opposite side of the angle. The opposite side of this angle is 8, so we're going to start with 8 squared. And once I pull out the 8 squared, the other two sides are 6 and 3. So it's going to equal 6 squared plus 3 squared minus 2 times 6 times 3 cosine of the angle opposite side 8, which is x. Alright? So that's how we do that. And so now we're just going to solve this little guy. 8 squared is 64, 6 squared is 36, 3 squared is 9, 2 times 6 times 13 is 156 cosine x. So now we're going to have 36 and 9 is 45. So we want to subtract 45 from both sides. And 64 minus 45 will give you 19 equals negative 156 cosine x. And then you want to divide by negative 156. So cosine x equals negative 19 over 156. And then at the very end of that, you want to take the inverse. Remember how we said before that when you want to solve for x, if it's the angle measure, you have to get rid of the cosine. And the only way to get rid of the cosine is to use the inverse of the function. You can't divide by cosine, okay? You have to actually take the inverse of both sides, and there goes my pen being funny again. Cosine inverse of cosine x, and then cosine inverse of both sides, negative 19 over 156. So here the cosine and the cosine inverse cancel, and you get x by itself. And here we want the cosine inverse. I don't know if you can see that there, but it's a little inverse. So we're going to use second cosine. That'll give you the cosine inverse function on your calculator. And then we're going to put in negative 19 divided by 156. And we're going to get, the answer is 96.99. They want us to round to the nearest degree, so 96.99 is going to round to 97. So x equals, or approximately 97 degrees for example 4. Alrighty. And I just noticed I did a little boo-boo here. That's not good. And that's right here. You probably already caught it yourself at home, but I typed in 13 for some reason. I confused this parenthesis with a 1. This is actually 2 times 6 times 3, and that's not 156. 2 times 6 times 3 is actually 36. So I'm really sorry about that. This is actually a 36 in there. And then that's going to change. This is going to be a 36 and a 36 and a 36. So basically it just, luckily not going to affect too much here, but it is going to be, our answer is going to be different. So instead of the cosine inverse of negative 19 over 156, it should be the cosine inverse of negative 19 divided by 36. And then our answer will actually not be 97, but will be 121.8, and that's going to round to 122. So sorry about that, but your angle measured there is actually 122 degrees, which makes more sense because the reason why I thought that was kind of weird is because this angle looks a lot more obtuse than 97. So I caught that little guy there, so it's actually 122 degrees. And so now you can try this little guy, and hopefully you won't make the mistake that I did and mistake parentheses for ones. And then we go to example 5, and this is actually more of an application problem. So I've gone ahead and drawn a diagram for you so you can see what's going on here. But basically it says that Drew and Hunter are playing basketball. And by the way, this isn't the only way that you could have drawn the triangle. We could have put Hunter and Drew down here. I mean, there's different ways you could have arranged it. But at the end of the day, the distances have to be in the right place. So Drew and Hunter are playing basketball. Drew passes the ball to Hunter when he is 26 feet from the goal. So here's Drew, here's D for Drew and G for goal and H for Hunter. So Drew passes the ball to Hunter when he is 26 feet from the goal. So Drew is 26 feet away from G. At the same time, he's 24 feet from Hunter. So here's the distance to Hunter. How far is Hunter from the goal? So how far is he from the goal? That's the X there. If the angle from the goal, so we start here, to Drew, and then to Hunter. So this angle right here is 34 degrees. So that's how I came up with the diagram. And they want us to find X. So this time I'm actually going to use my law of cosines because I'm going to take my X squared. I don't know what this little guy here is. X squared. I'm not sure why my pen's not on either. This really is not cool. It delays my videos, but it's okay. X squared, there we go, is equal to, so once I get the X squared out of the picture, then the other two side lengths are 26 squared and 24 squared minus, there's always a 2. Then we use the same numbers from here, 26 and 24, and then cosine of the angle that is opposite X. And the angle opposite X is 34. So there we go. And now we're going to just do the math here. This time, hopefully, we won't do it wrong. 26 squared is 676. 24 squared is 576. And then minus, let's do this right, 2 times 26 times 24 is 1248. Cosine 34. So 676 plus 576 is 1252 minus 1248 cosine of 34, and that's all equal to x squared. So if we want to know what x is, it's going to be the square root of that. So we're going to take second square root of 1252 minus 1248 cosine 34 degrees, close parentheses, and we get that x is approximately 14. It didn't tell us where to round, right? So we're going to go with 14.7. We're going to stay consistent with what has been in the past, round to the nearest tenth, and this is feet. So it's approximately 14.7 feet away from the goal Hunter is. Alrighty. So then we're going to go to, this is your do-it-yourself question. And then our last example for today is solving the triangle ABC. And it wants us to round to the nearest degree. So when solving the triangle, we've done this before, we did it with right triangles, we have to make sure first and foremost that this is not in fact a right triangle, because we don't want to use law of sines and law of cosines unless it's not a right triangle. So we can do that really easily by checking the two shorter sides, 12 squared plus 13 squared, and see if it equals 15 squared. So 12 squared is 144, 13 squared is 169, and 15 squared is 225. So 144 plus 169 is 313, which is not the same as 225, which is 15 squared. So because of that, we know this is not a right triangle, and because it's not a right triangle, we can actually go ahead and use the law of sines or the law of cosines. So we base our, we're going to have to use both at some point, but we want to base our decision off of the information that was given. So in this case, we're not given any angle measures. So we need to find at least one or two angle measures. We can find the third one by using 180 minus the other two, but we don't have any angle measures. And since we have all three sides, we're going to go ahead and use law of cosines to get started. So it doesn't really matter which one you want to start with. I'm just going to go ahead and start with 13. So I'm going to say 13 squared equals, and then I use the other two sides, which are 12 squared and 15 squared, minus 2 times 12 times 15 cosine, and we're going to say cosine of C because that's opposite of 13. So now my variable is angle C, and I'm going to find the angle measure. So 13 squared is 169, 12 squared 144, 15 squared 225, 2 times 12 is 24, times 15 is going to give us 360 cosine C. So 144 plus 225 is going to give us 369. So we want to subtract 369 from both sides. That's going to give us negative 200 equal to negative 360 cosine of C. Divide by negative 360 on both sides. We're going to get cosine of C is going to be equal to a positive 200 divided by 360, which is 5/9. And remember, like we said before, whenever you want to find the angle measure, you're going to have to use the inverse function. So cosine inverse of cosine C equals cosine inverse of 5/9. It's going to cancel here, so you're going to get C is approximately equal to cosine inverse of 5/9 is 56.25. They want us to round to the nearest degree, so we're going to round that to 56 degrees because it's 56.2. So 56 degrees for angle C. And now that you have one of the angle measures, you can actually now use the law of sines. So we can say sine of C, so sine of 56 over 13. This pen is driving me nuts. There we go. Sine 56 over 13. And let's just go ahead and solve for angle A. So then we're going to say sine of A over 15, because the side length that is opposite angle A is 15. And we don't know what angle A is, but we can find out very quickly here. So we're going to get 13 times sine A is equal to 15 sine 56. So we divide by 13, divide by 13. Oops, don't want to do that. Cancel it this way. So we get sine A is equal to 15 sine 56 over 13. And remember that when we're going to do our inverse, so we're going to get the inverse of both sides. Sine inverse of sine A, and then sine inverse of the right hand side as well. On the left, it's going to cancel out that. You're just going to end up with A. And so here we go. It's going to be kind of weird, but second sine inverse, and then we're going to plug in. I'm going to use another set of parentheses to put 15 sine 56 together. 15 sine 56. And then I'm going to close the first set of parentheses, and then I'm going to divide it by 13, and then I'm going to close the second set of parentheses. And I'm going to get approximate 73.05, but again, around to the nearest degree. So that's going to be 73. Once you have A and C, you can find B very easily by going 180 minus your 56 minus your 73. And angle B would equal 180 minus 56 minus 73. So B equals 51 degrees. And that's how you find A, B, and C. And in this case, we actually used the law of sines and the law of cosines to get all of the different angle measures. Alrighty, you could have used law of cosines each time, but I think the law of cosines is a lot longer than the law of sines. So now we're going to go to your do-it-yourself question. And again, you can use law of sines and law of cosines, however you want to figure them out, as long as you get all of the pieces of the missing triangles. So once you have completed this example, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.